Now on to that greatest of chemistry superheroes, Multimole. So in the last couple of videos, we have gone over the mole map. This idea that I can convert from volume to moles, particles to moles, mass to moles. All these one-step problems that go back and forth between some measurable value and moles. But what happens if I want to go, say, from volume to particles? There is no direct path between these two. I have to convert from volume to moles, then on to particles. 2 steps, 2 conversion factors that I will need. So for example, if we wanted to convert, we'll say 44 liters of oxygen gas, and I want to know how many molecules of oxygen there are in this sample. So again, I'm going to have to go from volume to moles, then on to molecules. 2 steps, 2 conversion factors. The first one, from liters to moles. Remember, any gas at standard temperature and pressure has a volume of 22.4 liters per 1 mole. So there's my first conversion factor. Now I need my second step, from moles to particles, and I use Avogadro's number. 6.02 times 10 to the 23rd molecules. I usually abbreviate molecules M-O-L-E-C because M-O-L is mole. Now my starting unit is present in liters. My ending unit is present in molecules. I'm good to set up my boxes. I'm going to need 2 sets. First box always is the number that I am given. 44 liters of O2. Took care of that piece there. I don't want liters. I want them to go away. Got to go down here. 22.4 liters is my conversion factor. I cannot move forward until I use my entire conversion factor. So 1 mole goes on top. Don't forget that this must be true. Top must equal bottom in these little conversion factors. Liters cancel. That leaves me with moles. I don't want that either because I'm going to particles. So 1 mole goes on the bottom. Here's my 1 mole. 6.02 e to the 23rd molecules goes on the top. So now we're going to multiply all the way across the top. Let's see if my calculator will fit on my screen. Oh, you can't see it anyway. Bummer. There we go. So we're going to do 44 times 1 times 6.02 times 10 to the 23rd. See if I turn on my light. That helped a little bit. Okay, so top here. Now we're going to divide by all the way across the bottom. It's a little out of focus, isn't it? So now we're going to do 24. I forgot my smiley face. 22.4. Oh, that's so much better. Times 1. So now we're going to divide top by bottom. Can you see that? Oh, yes, you can. Oh, good. So top divided by bottom tells me that I have 1.1825 times 10 to the 24th molecules of O2 in my sample of 44 liters of oxygen gas. Last thing to check is sig figs. 2 sig figs here. All I get are 2 sig figs here. Oops. So I have to round. Number, unit, thing. Let's try another one. This time, let's go from 56.82 grams of something or another. Iron sulfate. And let's take that to volume. Let's say what volume? Oh, that's not a gas. I need something that's a gas. I guess I could have done volume. I guess you could make that gaseous. we'll do C2H6. We're going to say that's a guess. I don't even know if it is, but we're going to pretend. So, on my mole map, notice I cannot go straight from mass to volume. I need 2 steps. I have to go from mass to mole, and then from mole onwards to volume. So, mass to mole, and then from mole to volume. Whoops. It would help if I could spell. Our conversion factor when we go from mole to mass is the formula mass. The formula mass, in case you forgot, is the sum of all of the masses of the atoms involved in our compound. So, formula mass for this guy, we're going to have 2 carbons and 6 hydrogens. So that's 2 times the 12.01 of carbon, and again, that is coming from the periodic table. There it is, right there. Hydrogen, 1.01. I'm not going to do that in my head. Calculator away. 6 times 1.01. 30.08 grams per 1 mole of dicarbon hexahydride. If you don't like that version, write it out as the conversion factor. That gets me from grams to moles. Now I need from moles to volume. It is still 22.4 liters equal 1 mole. That is true for any gas. Starting unit present, ending unit present, we're good to go. 56.82 grams. Nothing goes in the bottom left corner. Grams, I don't want them. Make them go away. 30.08 grams. Takes care of that first part. 1 mole on the top. Grams cancel. I'm left with moles. Still don't want moles. 1 mole on the bottom. 22.4 liters on the top. We're left with liters. Good thing too, since that is the unit that I wanted. Okay, let's multiply all the way across the top. 56.82 times 22.4 gives me 1272.768. Divided by, now we're going to multiply all the way across the bottom. We're going to see what that gives us. 42 point, how many sig figs can I have? 1, 2, 3, 4. So number, calculator gave me a big old number. Let's see, 1, 2, 3, 4 sig figs, so 3, 1. And that is in liters of C2H6. So that represents 2 examples of our multimole. Remember, you can go from anything to anything. On our molar map, you just need to make sure that you have a conversion factor for each step along the way. Best of luck in your further encounters with Multimole!